Hello everybody, myself Kamlesh Kumar. I am working here as a scientist in the Birbal Sahni Institute of Paleosciences. In today's module, I would like to introduce you the brief of the X-ray fluorescence and its applications. In today's module, the main contents are the basics of the X-ray fluorescence, working principle of the X-ray fluorescence, fundamentals of data generation, advantage of X-ray fluorescence, and its application in the earth sciences. Now comes to the basic theory of X-ray fluorescence. When a beam of X-ray falls on the samples, the atoms becomes ionized and moves out from its original space. Then an electron from the higher energy shell falls into the empty space and emits X-ray or characteristic wavelengths. This process is called X-ray fluorescence. The wavelength of electromagnetic waves is characteristics of the element being excited, and the measurement of this wavelength enable us to identify the fluorescing element. The intensity of the fluorescence depends upon how much of the element is in X-ray beam. Hence, measurement of the fluorescence intensity makes possible to quantitative determination of an element. Here, the diagram showing how an electron moves from the K shell and escapes out. An electron moves from L shell and fills the gap which is caused by the emitting of electron from the K shell, and when an electron moves from higher energy to lower energy level, it emits some energy in the form of the fluorescence. Here, the instrumentation and working of the X-ray fluorescence. This is the flow chart diagram of the X-ray fluorescence. The X-ray fluorescence is made up of two parts. This is X-ray generator part and second is the spectrometer part. The X-ray generator part consists of X-ray generator, sample chamber, collimator, and spectrometer part comprises of analyzing crystal and collimator. The basic principle of X-ray fluorescence is the dispersive detection system physically separate the X-ray according to their wavelengths, and the X-ray are directed to a crystal which diffracts according to Bragg's law the X-ray in different direction to their wavelengths. Here, the X-rays falls on the sample which causes the fluorescence, and after fluorescence the electromagnetic waves passes through the collimator and it falls on the crystal, analyzing crystal, which diffracts the different wavelengths to the again collimator, and finally the electromagnetic waves detected by the detector. Here the diffraction follows the Bragg's law, and only those electromagnetic waves are diffracted which are of constructive interface. Now the X-ray generator. X-ray tube for X-ray spectrometer is a diode, consists of filament generating thermoelectron and the anode generating the X-rays. Near the target there is a window to pass X-ray through to the outside tube. The window material beryllium is employed because of its nature for having the excellent transmission of X-rays. The X-ray tube, here is the rhodium is the main target which senses the effectively to the elements less than the atomic number 16, and it can also obtain relative the good sensitivity to the heavy elements. It can make the measurements from heavy elements to lighter elements without exchanging X tube. The frequency of using rhodium target X-ray tube is very high. Here the figure showing the element from where the electrons emits, and these electrons falls on the rhodium anode and the photons emits in the form of X-ray, which are known as X-ray photons. Now we are discussing the analyzing crystal. The diffraction phenomena of X-ray through the single crystal is utilized for the dispersion of X-rays. This crystal is called analyzing crystal. In accordance with the wavelength region of the fluorescence X-rays, the optimum analyzing crystals is employed respectively. Analyzing crystals such as sodium chloride, lithium fluoride, PET, and others are also used in the analyzing crystal. The fluorescence X-ray excited from the specimen are diffracted through the analyzing crystal by scanning goniometer. The diffracted X-ray are detected by the counter, and through the electronic circuit, the intensities are recorded automatically on the charge recorder. The characteristic wavelength emitted by each element in the sample is analyzed by applying a diffracting crystal which has a certain d value. Diffracting angles are measured and lambda of each element is determined using Bragg's law. By determining the elemental spectra recorded on a chart, we can learn the name of element containing in the specimen. Now we will discuss about the detectors. In the XRF, there are two types of detectors. One is gas field detector and another is scintillation detector. In gas field detector, the detection limit of element is from beryllium to the copper, whereas in scintillation detector, the detection limit of the elements is from copper to the uranium. The beryllium window allows to the photons in the gas field detector, and here also beryllium window, along with the beryllium window there are one sodium iodide crystal and PMT counter is also present. In gas field detector, the main gas is argon which is filled inside the chamber. The gas field detector works on ionization principle, whereas the scintillation detector works as a photomultiplied tube. Now the fundamentals of the data generation. X-ray fluorescence spectroscopy provides a means of identification of an element by measurement of its characteristics X-ray emission energy. The method allows the quantification of a given element by first measuring the emitted characteristic line intensity and then relating this intensity to elemental concentration. The energy of the peak leads to the identification of the elements present in the sample, that is qualitative analysis. However, the peak intensity provides the relevant or absolute elemental concentration, that is semi-quantitative or qualitative analysis. Now comes to the advantage of X-ray fluorescence analysis. As we know that X-ray fluorescence is a rapid analysis technique. It is a non-destructive analysis technique. No spectrum is affected by the chemical bonding. Easily analysis of the elements among the same family elements. High accurate analysis we can measure from boron to uranium, and easy qualitative analysis and easy sample preparation. Here we will discuss about the sample preparation. Initially, we ground the samples which is approximately 400 mesh. That can minimize the scattering effect due to the particle size. Additionally, grinding ensures that measurements is more representative of the entire sample to the surface area. Pressing compact more of the sample into the analysis area and ensure uniform density and better reproducibility. We can also analyze the solid samples, the oriented surface pattern in the same manner so as minimize scatter effect. Polishing surface will also minimize scatter effect. Flat samples are optimal for quantitative results. Now comes to the XRF application. During the last 2 decades, the development in the X-ray detectors has established the XRF methods as a powerful technique in the number application field, including ecology, environmental management, measurement of heavy metals in the soil, sediments, water and aerosols. We can also apply in the geology and mineralogy, quantitative and qualitative analysis of soil, minerals and rocks. The XRF can be used in the metallurgy and chemical industry, and quality control of raw material, production process, and finally products. Lastly, in the earth science, the data generated by the X-ray fluorescence in the form of major oxides and trace elements, we can interpret the earth surface processes, sediment rock interaction, weathering intensities, certain geochemical indices to reconstruct the provenance studies, past climate, past rainfall, and others are also applicable in the earth sciences. Lastly, I would like to say thanks for listening me and giving me your precious time.
Hello everyone, myself Kamlesh Kumar from Birbal Sahni Institute of Paleosciences. In theory class, I explain the working principle of the XRF. Here I am showing how the XRF works and hands-on experiment on the XRF. So initially we took the bulk powder sample which is homogenized and grounded, and grounded powder samples mixed with the boric acid in the ratio of 1:2. So we take 4 gram of boric acid and 6 gram of sample. We mix, homogenize, mix well, and we put in the hydraulic press machine, and we apply the 40 ton pressure, and we start to make the pellet. This is a pellet which is made by this hydraulic pressure machine, and after that this pellet is introduced into the sample holder. After making the pellet, now I will introduce you how the sample analyzed in the XRF machine. So this is the WD XRF machine. In the inside the machine there is a source, there is a sample holder as well as detector. So this is the pellet machine which is formed by the press pellet machine, and we put the sample in the sample holders like this. These are the sample holders. There are 64 sample holders. We can analyze 64 samples at a time. So this is the automatic sample sample changer which can change the sample automatically, and one by one goes inside the sample holder. So now I will show you how it works. See, the auto sampler will take sample automatically. It will go inside the sample holder. Once the sample will put inside, that door will close automatically. And now the X-ray beam will fall on the sample and diffraction will start. Now see, once the sample is start to analyze, here you can see the iron concentration is 1.6% in this particular sample. So thank you very much. I think you enjoy and you will learn the measurement of XRF measurement techniques, theory as well as the practical. Thank you very much.